Today we're going to be doing a teardown on the MultiCam fitness tracker. The point of this teardown is to understand the mechanical fastening features that are necessary when building a fitness or a smartwatch. 2 silicone bands and the device itself. So on the device itself we see a label. We'll get rid of that. Plastic housing. Dead giveaway here is the painted surface on the end of the device. Using the USB plug here for charging, so there's no pogo pins, there's no wireless charging. The device plug charges by plugging in. Goes the other end here, pops on, and you get a very clean, seamless form factor. Mold lines are continuous through the whole part. These silicone band parts are simple A-B with one side action. You'll see that the bottom surface is smooth, top surface is textured, and if you look carefully into the holes, we can see mold. Texture surface is likely a laser etched texture into the mold base. Here is a simple steel bracket, bent. I'm gonna look for surface coating. Could be a painted metal part. We're gonna try to scrape away some surface coating, and it appears there's no surface coating on the part, at least nothing that's coming off easily. Painted plastic lens with a small, it's subsurface. It looks like it's subsurface. I'm scratching the surface and it's not coming off. So that feature, either laser etched. So we'll see on the inside of the lens if that's a masking or what is creating that feature. Now we have a sensor on the backside with what appears to be a plastic lens and a couple of laser diodes, more likely a emitter and a collector. After cutting through an ultrasonic weld, it's holding the front housing in place. A thin circuit board on the inside of the display that's sensing the capacitive touch. And you can see we're somewhat translucent, but it's a smoked plastic front housing. So we'll look at this part in a little bit more detail. You can see a light pipe hole right here. This is the screen mask that prevents backlight bleed. And here's the capacitive touch button that's being sensed by this sensor right here. You can see this is just a die cut piece of black plastic. The display itself is painted subsurface or textured rather. The display is textured and glossy in the area where we don't want the light to escape. We see a fairly straightforward assembly method. Adhesive tape holding the board down. So here the vibrator motor is mounted into the housing of the device with a small rubber gasket. This gasket I can move around, or a small rubber boot. And if I pop that device out, it will sit on tabs, make an electrical connection with the PCB during assembly. What we're seeing here is a board stack. We have a display, we have a PCB, a battery, and a sensor board, where these are both soldered in place. So this is what's called a rigid flex board. We have a rigid component with 2 flex circuits attached to it. Sometimes if these are removable, we'll put a ZIF or a zero input force connector here. Pogo pins. Those 2 pins touch down on the USB pads. This rectangular feature is a vestige from a slide that pulls steel out from under this tab and allows it to be removed from the mold. These are ribs. Look like they're designed appropriately, roughly half the wall thickness of the part. Look close there, you'll see a adhesive tape. It's a ring. This is a ring of adhesive tape right here. This is an adhesive tape that's holding that lens in place. This is how you create a masked window. This is a clear lens with a back paint of black. And from the outside it looks like a glossy black. This housing was black, so you can see the paint comes right off. And these are laser etched markings on the painted surface. Laser etched markings on the painted surface. You can see the device is still functioning. A small lithium ion battery